Good day, ladies and gentlemen, friends and neighbors. Today we're going to finish up. I don't think we'll get finished, but we're going to look at Unit 0, Lesson 6, and this will be Part 2 of Unit 0, Lesson 6. And we did some rationalizing denominators on Part 1 video, but what the rationalizing denominator, boy, get it out, means get all the square roots out of the denominator. And we saw before, this is a major part of simplifying. This is a part of a simplified square root. So you cannot have any we can't have any square roots in the denominator. So that's part of a simplified square root we'll be talking about in video 1. So we're just going to review that and then do a couple examples and keep going, trudging forward with this topic. So notice 1 over square root of 2. The square root of 2 is in the denominator. It is not simplified. How do we take care of that? We multiply the 1 over square root times this guy right here is just another 1. And a times 1, we're using the important algebra 1 property that a times 1 is equal to a. Any real number times 1. This is the identity, multiplication identity. Doesn't change the value. That's why we can do this. And now we're just going to multiply the tops. 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2, we know this is 2. And now there are no square roots in the denominator. We know that 2 is prime. It has no perfect square factors. So we know that this rascal right here is simplified. Okay, and this is the simplified version of that. So let's rationalize or simplify this expression here, square root of 2 over square root of 3. Well, the only thing that's not simplified about that is that square root in the bottom. So what we're going to do is going to multiply it by 1 in the form of square root of 3 over square root of 3. Multiplying it by 1. And now I have square root of 2 times square root of 3 is going to be square root of 6. No perfect square factors. Square root of 3 times square root of 3 is 3. So this is the simplification of that guy right there. So that guy right there is equal to, as we saw, square root of 2 over square root of 3. And this is the simplified version of that. All right, moving forward. Now we're going to talk about a very important concept, multiplying conjugates. And what we're going to do is multiply conjugates of square roots. But these are two conjugates. This a minus b, the conjugate of a minus b is a plus b. And we've looked at some factoring binomial expressions in the last lesson, or it was maybe lesson 4, I'm not quite sure, lesson 3, but a minus b times a plus b is equal to a squared minus b squared. We're going to use that same process, or that same result, if you will, to multiply conjugates that are square roots. So here I have the same type of thing, square root of 2 minus square root of 5 times square root of 2 plus square root of 5, and that's going to equal 2 minus 5, which is negative 3. That's interesting. I mean, you could actually work that out if you could FOIL that. You're going to have square root of 2 times square root of 2 is 2. Then you're going to have square root of 10 and minus square root of 10. It's going to, well, let's verify it right here. We'll verify it with the distributive property, or FOIL if you want to call it that. I have square root of 2 times square root of 2 is 2. I have square root of 2 times square root of 5, that's a positive square root of 10. I have negative square root of 5 times square root of 2. That's going to be negative square root of 10. And I have square root of 5 times square root of 5. Negative square root of 5 times positive square root of 5 is negative 5. That, ladies and gentlemen, is equal to 2 minus 5, which is equal to negative 3. And you'll find out why that's important here in a little bit. So here we're going to whoa, right here it is then, why we're going to use that. Because I have to rationalize the denominator here. I got to simplify this expression. I got to get this guy right here out of the denominator. So what I'm going to do is I'm going to find a 1 to multiply that expression to get it out. So here is that 1. That 1 is going to be 2 plus square root of 5 over 2 plus square root of 5. And what did I choose? I chose the conjugate of this dude right here. The conjugate of 2 minus square root of 5 is 2 plus square root of 5. Now something magical is going to happen with the denominator, but and we can multiply the denominator first if you so desire. 2 times 2 is 4. 2 times square root of 5 is positive 2 square root of 5. Square root of 5 times negative square root of 5 times 2 is negative 2 square root of 5. You should see what's going to be going on here. Negative square root of 5 times 5 is negative 5. And now look what we did. Now in the denominator, the square root symbols are gone. They're gone. But before we simplify that, let's do the top, because we have to multiply the top as well. 4 times 2 is 8. I'm going to do this in a different color. Well, I said I was going to do it in a different color, and I didn't. And I'm going to erase that because that looks so bad. I'm going to come here and do this in black. 4 times 2 is 8. I have 4 times square root of 5 is positive 4 square root of 5. And I have square root of 3 times 2 is positive 2 square root of 3. And square root of 3 times square root of 5 is positive square root of 15. So we do want to definitely simplify that, rascal. Let me extend the page, and you have the bottom of your notes. So the top is simplified already. The bottom then is just going to be this. 8, the top is going to be 4 square root of 5 plus 2 square root of 3 plus 15. And then the bottom is going to be a single number. These cross off. These subtract away. So I have 4 minus 5 is negative 1. And you could leave that like that, or probably you would want to divide each term by negative 1. So it would be negative 8 minus 4 square root of 5 minus 2 square root of 3 and minus 15. That's the simplified version. I tell you, if you want to leave that rascal like that, you would be okay. If it were an IXL problem, this probably would be the answer. And all they're doing is dividing each term by negative 1. And you can do that since there's a single denominator. So let's do this guy right here. Let me get the record guy out of here. Make sure we're still recording. We are. So let's simplify this dude. And what are we going to do? Well, we're going to multiply that by the conjugate of the bottom. You can pause the video. What is the conjugate of the bottom? Pause the video. Okay. It's going to be 5 plus 3 square root of 2 is the conjugate. So we're going to multiply top and bottom by the conjugate. Keep in mind that guy is 1. That's why we can do that. And now let's start multiplying away. All right. Let's get all this stuff out of the way there. All right, so let's start multiplying. We'll just do the top. 2 times 5 is 10. 2 times 3 square root of 2 is going to be 6 square root of 2. So you just treat square roots like a variable. Square root of 7 times 5 is 5 square root of 7. And square root of 7 times 3 square root of 2 is going to be 3 square root of 14, 2 times 7. And on the bottom, we're going to get a single number, but let's figure out what that single number is. I have 5 times 5 is 25. 5 times 3 square root of 2 is going to be 15 square root of 2. Here's why I chose the conjugate. Negative 3 square root of 2 times 5 is negative 15 square root of 2. That's why you choose the conjugate, because you're going to get those middle terms to subtract away. And now I have negative 3 square root of 2 times positive 3 square root of 2 is going to be negative 9 times 2. 3 times 3, and a lot of people have a hard time seeing that. I'm going to write it up here. If I have 3 square root of 2 times 3 square root of 2, it's going to be 3 times 3 is 9. Square root of 2 times square root of 2 is 2. So that number is going to be 18 there. And so let's rewrite it with the simplified bottom, and you have 10. Top is going to be 6 square root of 2. Nothing simplifies here. Plus 5 square root of 7. Plus 3 square root of 14. All over 25. These things subtract away. All over 25 minus 18. And we know 25 minus 18 is going to be 7. So I'm going to put each one. Oops. Oh, that's kind of freaky. That's totally freaky. Still recording. I have no idea what happened. All right, well, let's keep on going then. That guy right here is negative. It's just 7, positive 7. So I'm going to put each term over 7. So it's going to be 10 sevenths plus 6 sevenths square root of 2 plus 5 sevenths square root of 7 plus 3 sevenths square root of 14. Looks kind of funky. Looks kind of difficult. That is the simplified version of this dude up here. And it looks kind of difficult. And you'll just have to, what's nice about the videos is you can pause the videos, you can think about the videos, fast forward, rewind. You can do it. Let's get on to the next part of this guy right here. And now what we're going to do, first thing we're going to do is move the record symbol. We're going to add these square root expressions. And when adding square root expressions, you're going to treat them as variables. And you can only add like square roots. You're going to add like square roots. There's a lot in this. This is keep in mind, this is a topic that we did in Algebra 2. Did a little bit in geometry. So this is kind of a tough topic that needs to be reviewed. And we'll have some good review exercises to go along with this. And you'll really need to take those serious as well. And then we can always take more questions during our Google Meets. Okay, the best way for me to explain what's going on is just do an example. So the first thing we're going to do is we're going to simplify these two square roots. I'm looking at this example right here. Okay, and square root of 8, we know from a previous discussion that that's equal to 2 square root of 2. Square root of 4, square root of 2. It's going to be square root of 4 is 2. This guy here, 12, you know what, let's do this. Let's go ahead and just review that. That's going to be square root of 4 times square root of 2 plus 4 times, there's another square root of 4 here, square root of 4, square root of 3. And this is going to be 2 square root of 2 plus 4 times 2, 8 square root of 3. And there is nothing, this is simplified. There's nothing I can add. I can't add those two things. But what, say for instance, I had this, though. Say I had square root of 8 plus 3 square root of 24. And let's try that in a minute. And you're going to see what's going to happen here. So we know that the square root of 8 is going to be 2 square root of 2. We know that. And we know that 24 is going to be 3 square root of 4 times square root of 6. And that's going to be 2 square root of 2 plus 6 square root of 6. And that is simplified as well. Okay, just for another example. Okay, so let's do another example of simplifying square roots. So we know the square root of 75 looks like that's going to be 5 square root of 25 square root of 3. Square root of 75 square root of 175 is going to be 9 times the square root of 25 times the square root of 7. Now I'm going to simplify those square roots of 25. This is going to be 5 times 5. This is going to be 5 times 5 square root of 3 minus 9 times 5 square root of 7. So this is going to be 25 square root of 3 minus 45 square root of 7. That's simplified. I'm going to throw a couple more examples in here. What if I had this dude right here? What if I had square root of 8? This is a new example. Square root of 8 plus 4 square root of 18. And I wanted to add those. Well, we know what square root of 8 is, how many times we're going to use it. This is 2 square root of 2. And this is going to be plus 4 square root of 9 square root of 2, because 9 times 2 is 18. So this is going to be 2 square root of 2 plus 4 times 3 square root of 2, which gives us 2 square root of 2 plus 12 square root of 2's. And now I can actually add those because those are like square roots. So the square root of 2 and square root of 2 are the same. So I can add those. So the final answer here is going to be 14 square root of 2. Okay? So we had 4 expressions here, and one actually simplified to one single term. And there'll be a lot more problems like this. So again, just to review. So here's a topic that is a review, also a review from Algebra 2, which is very important for next year. And that's this whole idea of the square root expression as a rational expression, as with a rational, and we're going to say a rational exponent. We want a rational number as an exponent. So this is called rational expressions or rational exponents. The square root of a is, this is the 2 right here. When you do the square root, you're just implying that it's the second root. The square root of a is a to the 1/2. This is going to be very important. This is taking the square root expression as a rational expression. The square root is a rational. And it's very simple. If I have the square root of 4, we know it's 2. But another way I can write the square root of 4 is 4 to the 1/2 power. Square root of 5 is 5 to the 1/2 power. That's just by definition of the square root. And here's something that we need to put in. So we're going to put a couple stars here. Star. We're going to add these notes in here. If I can do a star. The nth root of x is actually equal to x to the 1 over n. This is very, very important. We're going to have some IXLs, some simple IXLs to help with that. So let's continue with our discussion using that in what we already know. So I have 18 to the 1/2 and 8 to the 1/2, and I'm going to simplify that. Well, the first thing I'm going to do, I'm just going to write the 1/2 as a square root. So this is going to be the square root of 18 plus 2. There he is. There's that square root of 8. Well, and guess what we did? We did something similar to that. We know the square root of 18 is the square root of 9 times square root of 2. This is not middle air here. This is, got a little ahead of myself. 2 square root of 2. Well, no, it is 2 square root of 8. I was getting really ahead of myself. Well, we know that square root of 8 is 2 square root of 2, so this is going to be 2 times 2 square root of 2. There you go. Pause the video. That's correct. And then square root of 9 is going to be 3 square root of 2 plus 4 square root of 2. How many square roots of 2 do I have? This is going to be 7 square root of 2. And if I'm in rational, that can also write that rascal as 7 times 2 to the 1/2. And this is just depending on what type of answer someone is asking for. These two expressions are exactly the same. You can't multiply. It's not 7 times 2, 7 square root of 2. And we simplified the square roots and added the square roots. So if you look here, on this example, what do you have? You have two conjugates. This is equal to the square root of 5 minus 2. You don't have two conjugates. It's early in the morning. And you have square root of 5 plus 3. Those are not conjugates, as previously stated incorrectly. So what we're going to do, we're just going to multiply those rascals out. I have square root of 5 times square root of 5 is 5. I have square root of 5 times 3 is going to be 3 square root of 5. And I have negative 2 times square root of 5 is going to be negative 2 square root of 5. And negative 2 times 3 is negative 6. Now, if you notice, I can add these square roots of 5s. And this, I can add the 5 and the 6. The 5 and the 6 is negative 1. And I have positive 1 square root of 5. And that is the simplified version of this guy right here. All right, let's do 2 more examples here. And I'm just going to write that as simplified. It's 1/3 to the 1/2 power. 1/3 to the 1/2 power is going to be the square root. Don't want to do it in yellow. The square root of 1/3, which is going to be the square root of 1 over square root of 3. Square root of 1 is 1, so I'm going to multiply this by square root of 3 over square root of 3, which that's going to be square root of 3 over 3. And that is equal to 1/3 to the 1/2 power. So this is certainly going to take some practice, and we have lots of practice to give here. So I have 75 to the 1/2. One last example here. I have the square root of 75 plus 5 square root of 3. 75 is going to be square root of 25 square root of 3 plus 5 square root of 3. Oh, well, that is, these things were the same, because square root of 25 is 5 square root of 3 plus 5 square root of 3 is going to be 10 square root of 3. All right, so we will have plenty of written exercises and plenty of IXLs to review this very important and very convoluted topic. This is a tough topic, but I'm certain with much practice you will be able to become masters of this skill.